So the LeetCode problem we are going to solve is called balanced binary tree. Now we can see that this one is a LeetCode easy problem and also one of the most liked problems on LeetCode. The problem statement is quite straightforward, that we are given a binary tree and we need to determine that whether it's a height balanced binary tree or not. So the question is, what does height balanced tree means? It's actually quite straightforward. Height balanced tree means that at any given moment, the height of left subtree and the height of right subtree, if they do not difference more than 1, so which means that there is the maximum difference of heights is like 1 or 0. If that is the case, then we can say that this one is a height balanced binary tree, okay, or balanced binary tree. But if we identify, so let's try to understand. In this case, currently this one is our root node. Now if we see the left subtree, we can see that the height of this left subtree is 2. For the right subtree, the height of this right subtree is 3, which means the difference between left and right subtree is no less than or equal to 1, which means this one is a balanced tree or like height balanced tree. But in the same scenario, let's imagine that if we had one more nodes like this, then the height of this right side binary tree is going to be 4. Meanwhile, this left subtree is still going to 2. So if we do the difference of the height, we get the answer as 2, which is definitely greater than 1. In this case, we can say that now this binary tree is not a height balanced binary tree. Okay, so this is what we need to determine. Now this is like a very straightforward problem. Basically, at any given moment, we need to check that for any given node, what is the height for both left and right subtree, and this we can calculate very easily by simply traversing over the given tree in like any BFS or DFS fashion. And once we do the traversal at any given moment, we will have to keep track that for any particular root node, what is the height of its left subtree, what is the height of its right subtree. And if the moment we identify that the difference is actually greater than 1, then we can clearly say that this is not a balanced tree. If we identify that we iterate over the entire tree and we did not find that the height to be greater than 1 at any given moment between left height and right height, then in that case we can say that this one is a balanced tree. So that's it. This is all what we need to do. The approach is quite straightforward, and the idea we are going to use is that we need to traverse over the given binary tree. So for traversal, we know that there are iterative methods and recursive methods. Let's try to do it recursively. So recursively, we are simply going to iterate over the given tree. We need 2 items for the recursive case. First recursive condition is the base case. So base case is going to be that if the given current node is equal to null or 0, then we have basically exhausted every single child that we can visit for that particular tree. So we can do that. What is going to be the recurrence call that we need to make for the recursive level, that we are going to check that for any particular root node, first we are going to traverse its left child and then we are going to traverse its right child. So that is also good. Now while traveling, the moment we enter a new height or a new left child or a new right child, we are going to have a counter that is going to keep track of the left height, and we are also going to have a counter that is going to keep track of the right height. We are going to update it sequentially with every single level that we are increasing, and during every single update we are simply going to check that if the difference between left height minus right height, and we are going to do an absolute difference. So we don't care about which one is greater, as long as the delta is greater than 1. The moment we find this one, we can say that this one is an invalid or not a proper height balanced binary tree. And if we reach to the end, we can say that this one is a height balanced binary tree, and we can return this answer very easily and very simply. So the approach is quite straightforward. If we see time and space complexity, in this case the time complexity is simply going to be big O of n, where n is the number of nodes that are present. For the space complexity, because we are using recursion, we will have to induce or create a new recursive stack, so that might increase the time complexity to big O of n. And if you try to do this recursively, you can also do this in big O of 1 space complexity as well. But I don't think like any interviewer is going to have any issue of you using recursion, because that is a great way to save some time. And now let's quickly see the coding solution for this one. So if we see the solution, it's quite straightforward. We need to return a Boolean answer that whether the given tree is balanced or not, and in the input we are given the root. Now first we check for our base case that if the given root is equal to null, we can simply return true. If that is not the case, we are going to calculate the left height and we are going to calculate the right height For that, we are going to use a helper method called getHeight, and we are going to pass in the root value. Now inside the getHeight method, we are also going to check recursively that whether if the given node is equal to null, we can return 0. If that is not the case, we are once again going to recursively call the same method for the left child and for the right child. And at every given instance, we are simply going to calculate the maximum height we have been able to find both for left height and right height, and we are going to add +1. So this is going to give us the height at any given left subtree and right subtree that we are going to fetch values over here. Then we are simply going to have our math.absolute formula that if the difference is greater than 1, then we can simply return false. If that is not the case, then we simply need to say that yeah, if this given tree is balanced. So that's it. This is the whole solution. We can simply run the code, and then I think it should be working fine. Okay, seems like our solution is working okay. Let's submit this code. And our code runs 100% faster because there are very few test cases. So this is pretty awesome. Now, once again, this whole solution is actually posted on our GitHub repository that you can find over here. Now, this GitHub repository contains hundreds of very popular every single LeetCode problem that you can imagine, and for each and every problem I have also provided that what is the LeetCode problem statement for that particular problem, what is the Java solution, and for some reason if you cannot understand the solution on your own, you can actually go to the video solution as well. I have provided the link. So this is a great resource for anyone trying to prepare for LeetCode or DSA problems. The other thing is, I also want to show you one more resource that I have created, or not the LeetCode one, but the document that I have been able to curating. Now this document contains two very important lists. First list is the most popular and liked technical interview questions of all time. Now over here, I have created a list of 130 questions. For each of these 130 questions, I have divided them based on the topic that you need to prepare. And I have also provided the key important information that how many times that particular question has been asked at what type of company. So this will help you in a couple of ways. Number one, you would be able to understand if you're targeting any specific company, you can find that how many times that question has been asked at that company. Number two, based on just looking at the question, you can understand that how important that question in general is. So some questions have been asked like literally hundreds of times by many top tier companies. So you should be able to identify that as well. And each of the topics are distributed based on like easy, medium and hard LeetCode problems. So that is one option. Second one is the LeetCode 150 list that I'm currently working upon. So this is like the 150 most asked questions list created by LeetCode. That is an addition to Blind 75. Now this is also a very pretty and very important list. Once again, all the questions are differentiated based on topics. We can also see that for most of the questions, I'm trying to go through them and generate solutions for them as well. So yeah, if you want, you can also check out this resource. Maybe it can be helpful with your prep journey. Okay.